Welcome back to Dreaming Against the Machine. I'm your host, Adam Becker. This week's guest is Katie Mack. She's a cosmologist and science communicator, author, and the Hawking Chair at the Perimeter Institute up in Canada, Theoretical Physics Research Institute. Katie is also a friend of mine, and I brought her on because I wanted to have a conversation about the way that thinking about the deep cosmological past and future can change your perspective on things here and now, because that's a big part of how I think about the world. You know, I did my PhD in cosmology and spent my waking hours thinking about the deep past of the universe and to some extent the future. And Katie has spent a lot of time thinking about both of these things. She's written a whole book about the end of the universe as we understand it. And I think that even though the end of the universe can maybe be a depressing subject, first of all, it's billions of years away. And second, I think that it is something that I sort of maybe perversely draw some hope from. And I think that bigger perspective is an important part of thinking through how we want to change our relationship to the world around us in order to make it through these problems and crises that we as a species face right now. So here's Katie Mack. Katie Mack, welcome to Dreaming Against the Machine.
Thank you. I'm very happy to be here.
We're happy to have you. I feel like most of our listeners probably already know who you are, but for those of you who don't, Katie is a physicist and renowned science communicator and author, and she works at the Perimeter Institute up in Canada, which is a really amazing place that I have been to a couple of times at Katie's invitation. I should have said it's Katie's fault, you know, going. But yeah, and also the author of The End of Everything, which is about the end of the universe and is related to what we're going to be talking about today, and also has an upcoming book, the title of which is
How to Build a Universe.
Okay.
So the first book is The End of Everything, and then in parentheses, astrophysically speaking.
Yep.
And the second book is How to Build a Universe, and then in parentheses, theoretically speaking. So it's about what the universe is made of, how we know about that, how we build theories about what the universe is made of. And it's, as the first one, it's sort of general public level, you know, it's not a technical book, but it does get into some very interesting ideas, I think. So
I feel like there's kind of a you break it, you bought it kind of thing here. Like the first book is about how to end a universe and the second book is how to build one.
It was hard because the first book was about the end of the universe, and I wanted to write more about cosmology, but you can't write more books about the universe when you've already destroyed it, right? And so I thought, like, maybe this one will get more into sort of particle physics and stuff like that. And so it's not about sort of the history of the universe or even the beginning of the universe. It's more about, like, how does fundamental physics work? Like, how do particles work? What are they? How do they fit together? How do we think about the relationships between particles on the subatomic level? How do we come up with ideas for that? How did we discover all these things? And how does that relate to what we see in the universe? So, you know, there are things out there in space where the particle physics of what's happening is very important for what those things are. And so we, you know, go through like how quantum mechanics relates to neutron stars and how things that happened in the very beginning of the universe changed how particle physics works today. So it's kind of that connection between the tiniest things and the biggest things in the universe.
I realized, though, that when I introduced you, I left something out. What is your research on?
So I do a few different things. So my research is cosmology, theoretical cosmology, broadly speaking, cosmology being the study of the universe from beginning to end, from the smallest to largest scales, like how the universe works.
Yep.
And the areas I focus on are mostly dark matter, which is some kind of invisible stuff that holds galaxies together. dark energy, I've done a little bit of work on that. That's something that's making the universe expand faster. And then I study sort of early universe stuff occasionally. So, how the universe came to be what it is, and end of universe stuff occasionally as well. And just random little interesting things along the way in all this direction, stuff about black holes or explosions in space, whatever, things that catch my interest. So the main thing is that I don't work with data, but I also don't build new theories. So I'm not a model builder. I kind of work in between the theory and the data. So I'm interested in, if the theorists come up with this cool new idea about dark matter, and then the astronomers have some cool new telescopes, like what can you learn from the observations about the model, and, what kinds of models are interesting to test with observations, that kind of thing.
No, and this is not too far off from the area where I did my PhD in cosmology. And actually, I correct me if I'm wrong, I think that's how we met. We first met, I think, in 2011 in the Azores.
That sounds right. Yeah, the Phi in the Sky conference.
Yeah, it was a summer school for a thing.
That was a lot of fun.
But the main reason I brought you on here today, aside from the fact that, we're friends and you're delightful, is that this is a podcast that's sort of about thinking about what a good future might look like, and thinking about the future is in some ways like what your first book is about and really I wanted to talk with you about staring down the end of the universe. Okay, so many years ago, when I was first starting out as a journalist, I wrote an article about the end of the universe for, I think it was the BBC. And I sent it to a dear friend of mine. And he had been, reading everything that I'd been writing with interest. And he said he wasn't going to read that one. And I said, why? And he said, because when I think about the end of the universe, I get depressed. I said, I can think about the end of the world, but thinking about the end of the universe is somehow way more depressing for me. And I feel like that's actually a reasonably common reaction. So I want to talk about, how do you deal with that? And then we can, talk about that.
So one thing that occasionally comes up when I talk about the end of the universe is people want sort of a way out. And I have to say, in terms of what we understand about the science of cosmology, it doesn't end well, right? like the universe is gonna end at some point in some way, and we get to that basically just by looking at how the universe is evolving now and seeing that, like, there are lots of different ways things could happen in the future, but all of them trend toward decay or, disorder of some kind, or a sort of fizzling out, or something catastrophic. Like there's always something, there's nothing that we know about that could keep the universe in its kind of happy, habitable state forever.
Right.
Just in terms of how physics works, how the second law of thermodynamics says that things trend toward decay, all of that kind of points to the universe is going to end at some point in some way. And when I say the universe is going to end, I mean everything that exists in the cosmos today will be destroyed. Right? And at some point, new things will not be able to exist in some fashion, right? And I think that that's upsetting to people more than it's upsetting to people to think about, like, their own death or the death of the Earth, because we like to think that we will have a legacy, right? Like when people think about their own death, a lot of times the thing that's comforting, is the idea that, well, maybe my the future generations will remember me. I'll have some impact on my children, and then that will make the world better, or like there's some trace of me, my great works will live on, whatever, right? Like there's some idea that you have a legacy of some kind.
Like your books about the end of the universe, for example.
Sure, exactly. And so you can kind of find a way toward immortality just by the fact that we all have effects on the things around us, and we all affect the future in some way. And if the whole universe is going to end, then that gets you to this place where at some point it will not have mattered that we existed, right? Like at some point that memory will be erased and there will be no legacy at some point in the very distant future if the whole universe is going to end. And that's true even if there are sort of cycles of existence, like they destroy the previous cycle. In some theories, there can be a new Big Bang where some information passes through, but it's generally not going to be like the story of your life, right? Like it's very hard to find a way where the end of the universe is able to preserve a legacy. And I think that that's what people find so existentially terrifying about the end of the universe. Not just not just that I will die, but that all memory of me will die. It will not have mattered that I lived. Like that is more personally affecting, I think, than just the idea that like my subjective existence will end. And so I think that that's what people find troubling. If people have sort of religious ideas about afterlife or some ultimate meaning, then maybe they don't look at the scientific view and take that as fully complete. I have nothing to say about that.
Sure.
Scientifically we can't address that, right?
Sure.
But I think for me, and I don't have this idea that some higher purpose is going to come in and make it all worthwhile in the end. That's not where I'm at.
Yeah.
For me, the idea that everything is going to end and that there will be no legacy makes it so that it's absolutely necessary, if you want to have any meaning in existence, to find that meaning in the moment.
Yeah.
Today, that something that does not depend on the future, does not depend on some ultimate reckoning or some, it all makes sense in the end. Like you have to find a way that existence has meaning now.
Yeah.
And that I find actually really useful as a way to think about existence. Because even if I did believe in some afterlife, some ultimate meaning, I wouldn't have a guarantee of that, right? Like I don't know for sure. But if I'm finding meaning in existence now, if I'm finding meaning in everyday life, in the experiences that I have in the moment, then that is robust, right? That it doesn't matter what's going to happen in the future. I can have that meaning now, and I can feel that there is purpose in life. And that's important to me to find that. And, and it's subjectively created meaning, like it's not handed down, but that's something that's important to me to feel like I can live a meaningful life.
I think you're right. But the word that was coming to mind for me when you said that, you find it useful to think about finding meaning in the moment, instead the word that came to mind was liberating.
Yeah.
It's freeing in a way. And I don't mean this in a like nothing matters, so you can do whatever you want kind of freeing, because I don't think that that's true. But I want to push back a little bit on something that you said. I don't know, maybe this is me going a little bit too galaxy brain with the end of the universe.
Okay.
But when I think about this, I think about the fact that time is another dimension. And so there are locations in time just as there are locations in space. And so, yes, at some point in the future, all record of us will have been erased, but that doesn't mean that we're not here now, which is, I suppose, another way of saying what you're saying. But it's always going to be true that we are here now, even if there's no record of it.
I guess that no record is crucial to the way that I think about it.
Sure.
That there could be the subjective experience of an observer in the future for whom our existence does not matter. And never did.
Yeah.
And I think that that's sort of troubling to people. I mean, at the same time, there could be subjective observers in other parts of the universe that are just so far away from us that we have no effect on them,
or so far in our distant past that we don't
that they didn't affect us. I mean, there are different ways to think about it. I think the process of being forgotten is troubling to people.
Yeah.
Right. So
yeah,
there is a sense of forgetting in the destruction of all reality. Right?
So let's dig into that, and then we'll sort of come back to these questions about how we feel about it and how we live in the face of that. what are the ways that the universe can end? Let's, I mean, I know some of this, but you know more about it than I do.
There are lots of different ideas for the distant future in the cosmos. In my book, I covered 5 in terms of sort of broad categories. The one that I think that people have mostly heard of, which is not at all favored by current data, is the idea of a big crunch. So right now the universe is expanding. It's been expanding since the beginning. And sometime in the 60s, the popular idea for the future of the universe was that the expansion would stop, turn around, everything would collapse together again. And that's the big crunch, right? That doesn't work well with the current data. The current data is showing that the universe is accelerating in its expansion.
Yes.
Exactly what that acceleration looks like, people are arguing about right now because there's interesting new data there, but there is this acceleration of expansion, and that points us to this idea of dark energy, which is something that's making that acceleration happen. And in the presence of that kind of dark energy, it's very unlikely for the universe to stop and recollapse. So that's probably not going to happen. I say probably because we don't know. We don't know what dark energy is. Maybe it will turn around in some way. Maybe whatever's making the universe accelerate now will cause it to decelerate and then compress. We can't say for sure. But the current understanding is that it's unlikely. And I should say, even if the universe were going to collapse, even if a big crunch were coming, that doesn't guarantee that there's going to be another cycle. Like that, the idea that we collapse and then re-expand, that's actually quite hard to realize in a model, in a theoretical model. You have to do complicated things to make a re-expansion happen. If you just take the equations of general relativity, Einstein's gravity, then you can have a big bang at the beginning, you can have a big crunch at the end, and there is no process for transitioning between the two. So I always want to put that caveat out there because I feel like people assume that, oh, a big crunch, then we get reborn, and not necessarily.
Yeah.
That's actually complicated. But anyway, so we think probably not a big crunch. If the dark energy is what we call a cosmological constant, so just like a sort of property of the universe, it's just a thing that's part of how space works, then that leads us to this idea of what we call a heat death, which is sometimes called the big freeze. And that's where the universe just keeps expanding and accelerating, expanding, accelerating, and everything kind of spreads out so much that stars stop forming, things get diffuse, everything decays, black holes evaporate, matter falls apart, and you end up with a universe that's effectively empty, cold, dark, nothing is happening. And that's called the heat death because in this context, heat has to do with sort of disordered energy, and you get to this point where the entropy of the universe, the sort of disorder of the universe is maximized, where, if you take this second law of thermodynamics that I mentioned before, it's this idea that the entropy or disorder increases into the future. And with heat death, you eventually get to the point where the entropy is maximum, so it cannot increase anymore. And that essentially means there cannot be a future, which is a complicated thing technically, but that would be what we would call the end of the universe in that scenario.
Everything's just the same everywhere, and just random
little fluctuations. Yeah, but nothing really happens anymore.
Yeah.
There are other things that could happen if dark energy is weirder than we think. So if it's changing in certain ways, you could have something where the acceleration increases more quickly than we expect, and that could kind of rip the universe apart. It's called the Big Rip. Probably that breaks some rules about how energy is supposed to happen in the universe, but that's one of the scenarios people occasionally talk about. And then you can have things like cyclic cosmologies where the universe can evolve toward an ending and then a new beginning. Sometimes that looks like more like a big crunch. Sometimes it looks like a heat death, and then a new universe sort of sprouts out of that. There are a couple of different ways that could happen that people bounce around, but none of those are like as developed as the models where there's just an ending. And then one of the weirder possibilities is something called vacuum decay.
Yeah.
Where the universe is, going along, minding its own business, and then a quantum event happens somewhere in space that creates a bubble of a different kind of space with different laws of physics, and that bubble envelops everything and destroys the universe. And that's a fun one because technically, like, we couldn't predict when or where that would happen if it's something that could happen. And so it could happen anytime, really. It's very unlikely to happen anytime soon, like, based on our estimates of the rate of this occurring. It's, so far in the future, basically everything's over anyway. But this is one of the possibilities that people talk about, where you get this interesting connection between the particle physics and the cosmology, because it's a particle physics process that would drive this. So those are the five that I cover in my book. But there are kind of other possibilities, but they're all kind of in those classes where the universe either compresses, expands, or has some kind of decay process like vacuum decay, or you have something cyclic. So those are kind of the directions you can go. None of them are just like, we all live happily ever after. Like, that's not that's not one of the options.
No, it's not. So I have so many different directions I want to take this conversation, but
Okay.
first I want to focus on that last scenario, vacuum decay.
hmm
There was a moment in your book, in the end of everything, that I particularly liked, and I think you know what I'm referring to. I think it's the opening of the chapter where you talk about vacuum decay. And you say, like, I remember the moment when I realized that the universe could end at any minute without any warning.
Yeah.
Can you tell our listeners about that?
Yeah. So I first learned about this possibility in the context of sort of inflation, which is this process that we think happened in the very early universe that has certain things in common with vacuum decay. But I was in undergrad. I was a undergrad at Caltech, and there was this sort of seminar class where the way it worked was that all of the astronomy students, there are only like 15 of us or something, would go to the home of one of the astronomy professors, and they would give us like pie, and we would sit around and chat, and they would tell us something about their life or their research or whatever. And it was a way to kind of so we get to know the professors and get to know each other. And
so it was
and
a
all
different
that.
professor
And
every week.
it was a different professor every week. Yeah.
Okay. Yeah.
And so one day we went to Professor Stroll Finney's house, and he was my undergrad advisor, so I knew him pretty well. He works on like gravitational waves and stuff like that.
Mm-hmm.
And he was sitting there, and he had his little daughter on his knee, and his daughter was like 3 years old or something. And he was, chatting to us about the universe, and he started talking about this process of inflation that happened in the very early universe. And he was like, yeah, and we don't know why that happened, and it could happen again at any time. We have no idea. It's just like, what? This was like a kind of universe tearing apart kind of process. And it made me realize, like, yeah, there are things that we don't understand about about things that we know happened in the past in the universe. Big universe changing, structure destroying processes that we're pretty sure happened at some point. And even if inflation were not 100% certain happened, there are other big universe changing processes like a transition in the Higgs field in the early universe that's connected to the vacuum decay process, where like big things could happen in the universe and could actually affect us. And because we don't understand them, we cannot predict them. We cannot say that they're not going to happen right now. And at that time, it kind of freaked me out, like just this idea that we are subject to the whims of these sort of cosmic tides that we don't understand and can't predict and have no control over, absolutely none. It was a sort of confronting moment, and especially weird because there was this like little child, and Professor Strollfinney's up there like kind of smirking about it, and this little girl is just like da da da. And I'm sitting there having an existential crisis, feeling like I'm no fall through the floor at any moment. So yeah, it was an odd experience, and I can understand how when other people learn about vacuum decay, they can have a similar kind of like, oh my God, moment. And I think that the way I ultimately came to, a place of peace with that was realizing that there are just a lot of things in the world that we can't control. I mean, people talk about a meteor strike, and that's more likely than vacuum decay by many orders of magnitude.
Yep.
Like getting struck by a meteor, even though only one person in the history of the world has ever been struck by a meteor, as far as we know.
Yep.
Meteorite, I should say. That's like a more probable thing, and that's extremely unlikely. But I could get hit by a car riding my bike,
Yep.
or crossing the street, or succumb to some consequence of climate change, whatever.
Yeah.
Like all of those things are big, big uncontrollable forces that have the possibility of affecting my existence, and I don't control any of those. So I think that what changed for me was I got a better understanding of the fact that there are a lot of things in the world that we don't control, that we can't control, and most of them are not worth thinking about at any given moment, because what are you going to do, right? Even if I spend all my time freaking out about vacuum decay or cosmic inflation or meteorites, what am I going to do? Nothing. It's better to live my life as though that's not going to happen, or live a life as though it could end at any moment and just kind of find peace with that, right?
Yeah.
But constantly freaking out about it is not going to help me. And so it's funny because I do get messages from people who have that response to vacuum decay, and they write to me and they say, I can't sleep. I heard about this vacuum decay thing. I'm full of anxiety.
Oh, God.
And they want me to tell them it can't happen. And I'm like, I can't honestly tell you it can't happen. I can tell you should talk to somebody. But what I want to tell them is, you're worrying about this very unlikely thing. You should just accept that there's a lot of things in the world that you can't control.
Yeah.
and this is the least important one. There are other much more important things that could kill you that you can't control.
Yeah.
And I don't tell them that. I mostly, if I respond, I mostly tell them they should talk to someone about it, because these are experiences people have that take some discussion sometimes to find peace with. But yeah, it's I think that we as a species, a lot of us are at a point technologically where we have a lot of control over a lot of things in our lives, and so we want to think that we can control all these big things, and we can't.
I feel like we have the illusion of control over a lot of things.
Yeah.
I don't think that we actually have that control. One of my favorite authors, who's a problematic fave, and I'm not going to name him as a result. But he said something in one of his books once to the effect of, we don't have control over 99% of the things that happen in our lives, and most of the remaining 1% is whether or not we're going to accept that fact.
I can control what I'm going to have for breakfast. I can control how I'm going to spend my paycheck. There's a bunch of things,
sure,
where I can choose what kind of car I drive. There are a lot of things that are in my control, and I think that's more the case than it has been for most people throughout the course of human history.
Yeah.
And so that leads us to think we have this level of autonomy, of volition.
Yeah.
That, as you say, we just don't at some fundamental level.
And the likelihood here that we're talking about is, I mean, you were saying it's much less likely than being struck by a meteorite. It's also much less likely than the entire planet being struck by a giant asteroid like the one that killed off most of the dinosaurs 66 million years ago.
Yeah.
So there are other things that would end human civilization or even the human species that are way more likely.
I tell people, you're much better off going out and campaigning for green energy or checking your smoke detectors, right? Those are the things to put your effort into.
Yeah. Where's your fire extinguisher? Do you have a carbon monoxide detector? Yeah. Unfortunately, we still live in capitalism, and that means we need to talk about our partners and sponsors. But fortunately, our partners and sponsors are great. And if you want to support Dreaming Against the Machine directly, you can join us on Patreon, where $5 a month gives you the chance to ask questions of upcoming guests and a dedicated stream of cat pictures. We love our patrons, and we also love being a part of the Multitude Collective at multitudeshows.com. Multitude is a podcast company made up of passionate people creating shows you can count on. Shows like Wow If True. Wow If True is your one-stop internet culture shop. explaining how what's happening online shapes the real world. The hosts, tech culture journalist Amanda Silberling and science fiction author / attorney Isabel J. Kim, Esquire, are internet experts and real-life besties asking and answering your burning questions about the internet. Why are the edgelord tech bros literally everywhere, even in the White House? Are the AI overlords coming to take our jobs? And if so, why are these AIs so awful at playing Pokemon? It's the only podcast that will mention Neopets and horizontal mergers in the same episode. So check out Wow If True wherever on the internet you find your podcasts. New episodes every other Wednesday. And here's a word from our sponsors. One of this week's sponsors is Shaker and Spoon, a monthly cocktail and mocktail subscription. Full disclosure, they sent me a free box this month, and I'm excited to try it on a night off soon. Each box includes 3 original recipes from award-winning bartenders, with enough ingredients to make 4 of each of those drinks for at least 12 drinks in total. And each box includes everything you need to make the drink except for the alcohol. And they're built around 1 spirit per box, so you really just need 1 bottle of something that you probably already have on hand if you drink. And if you don't drink, every box includes 0 proof options for every recipe, and some of the drinks are designed to be completely spirit-free from the start. The boxes come with recipe cards that include guidance on mixing techniques and glossary of terms that teach you how to shake, stir, build, and garnish these unusual cocktails with eclectic ingredients. And they also include everything else that you need to try out these drinks, like custom syrups, bitters, extracts, garnishes, and aromatics. And so you can try the drinks without going off and buying full bottles of niche ingredients that you'll never use again. It's a great idea for date nights or hosting a party or bringing a gift to someone else's party. And you can always skip or swap boxes or even just buy individual kits or ingredients without subscribing. So you can try this stuff out at their website, shakerandspoon.com. Use code DATM for 10% off your purchase. Just to give a vivid example of this thing that we shouldn't worry about, though, I want to make sure that my understanding of it is correct and also convey it to our listeners here. So vacuum decay is when there's a random quantum fluctuation at some point in the universe that, to the best of our knowledge, happens for no reason. And then that leads to a bubble of a different universe with different laws of physics, expanding at the speed of light with no warning that destroys absolutely everything in its path.
Yeah. So it all has to do with the Higgs field, which is this sort of energy field that exists throughout all of space. And the Higgs field is connected with how particles work in our universe. It's connected to how certain particles have mass, how they interact. And
there's a boson for the Higgs field that was discovered at CERN in 2012, very famously.
Yes, they detected a particle that's connected to the Higgs field. But the Higgs field itself is kind of what we're talking about here, and it's just this kind of energy field, and it has a value. It has a sort of number associated with it, and a kind of an energy associated with it. And in the very, very early universe, that value was different. The Higgs field changed. And when it was different in the very early universe, we had different laws of physics. We had different kinds of particles, different kinds of forces between particles. None of the particles had mass. And then there was a transition that changed the Higgs field. And when that transition happened, it set up the laws of physics as we know them. This was called electroweak symmetry breaking, if you're interested, but this is the process that happened in the very, very early universe. And the problem is that there are certain theories, certain ways of looking at our understanding of the standard model particle physics today that suggest that a transition in the Higgs field could happen again. That it's kind of like if there's a ball rolling down a hill and there's a little divot in that hill and it could get stuck in that little divot, then it could stay there. It's, pretty stable, but if it gets nudged a little bit, it will keep rolling down the hill. And the problem is, it seems like maybe our universe is like that little divot, like the Higgs field got stuck somewhere, but something could happen that could push it over the edge. And we don't think that a process would push the Higgs field, but quantum mechanics says that there's some variation in kind of everything, and all fields have this kind of like fluctuation. There's a little uncertainty about where that ball really is in this analogy, and that could lead to it quantum tunneling or just kind of showing up on the other side of that barrier, rolling down the hill some more. And if that happened, if somewhere in the universe some piece of the Higgs field did that quantum transition, that quantum tunneling event, then it would be in this lower energy state that's preferable, and it would pull all of the Higgs field around it into that lower energy state, like a chain falling off a table and pulling the rest of the chain with it. And that would create a bubble of a new kind of space. We call it a true vacuum. And this is just, that vacuum doesn't mean it's truly empty. We live in a vacuum state. There's a state of the universe that we call the vacuum state. Just means this is how the universe is set up. This is how the laws of physics work.
Yeah.
But if we are in that little divot, then that's a false vacuum. The true vacuum is the bottom of the hill. So it would create this bubble of this true vacuum state. And inside that bubble, the laws of physics would be different. Particles would have different masses. They would interact in different ways. We would not be able to, our molecules would not hold together anymore. Our atoms would not work. And so if we ended up inside that bubble, we are destroyed in a big way. And that bubble would expand at, as far as we know, about the speed of light, which means that you would not see it coming. As soon as the light from it gets to you, it is on top of you and destroying you.
Yeah.
And it would just kind of destroy everything that it touched. And so there's a sense in which this event would be, it would certainly be painless, right?
Yes, it would happen far too quickly. Yes.
Yeah, if it travels at the speed of light, your nerve impulses don't travel that fast. You wouldn't feel it. You wouldn't notice it.
Yeah.
You'd just be gone. There's no like tragic aftermath. So in some sense, it's a very peaceful way to go. But people find it troubling because it would kind of destroy everything. And the thing is that the idea that we are in that little divot, that we are in this, what they call a metastable state, that calculation comes from the idea that the standard model of particle physics, our current theory of how physics works in our universe, the idea of vacuum decay comes from the idea that is the whole picture of how physics works in our universe. And we're pretty sure it's not. We're pretty sure there's more to physics than the standard model, that there's some other maybe quantum gravity or something that might change that picture. And so we don't know for sure if it could happen if we are in that metastable state. If we are in that metastable state, you can do calculations about how long it'll be before that transition happens. And usually the answer you get is like 10 to the power of 100 years. But that's a decay rate, right? So it means that like on average, it would happen after that amount of time, meaning that like in any quantum event, you can't say exactly when something's going to happen. You can give a decay rate for like, radioactive decay or something and say there's a half-life, right? There's a certain amount of time where half of your material will decay away, but you can't say it for any individual atom when it's going to happen. So that's why, technically it could happen at any moment. But when you have a decay rate that's that long, 10 to the power of 100 years or more, you don't expect it to happen soon.
And so that's why it's so phenomenally unlikely, and so many other things are so much more likely, like getting hit by a car.
Yes, exactly.
Okay, so I think this episode is sort of turning into I ask you questions that people have asked me as a cosmologist.
Okay. Sure.
But I'm thinking of another thing here as well that feels relevant here. I have another friend who, again, will remain nameless because I don't want to embarrass my friends and ask them for permission to bring them into this conversation. Okay. She doesn't like looking at the sky and doesn't like at the night sky and doesn't understand how I, researched what I researched for my PhD, what you do what you do for your work, without feeling really like helplessly small and insignificant. And I feel like this is related, right? These are questions about perspective.
No, I totally feel helplessly small and insignificant. I just think that's good.
Yeah.
I just like, can you imagine if we were significant, if we could impact the universe? Like, we're not doing a great job on this planet, right?
No, yeah. Yeah, yeah,
Like, I
yeah.
don't want to destroy the cosmos as well. Or, I
Yeah.
mean, I don't know. I think it's kind of liberating to know that, like, however I screw up, I'm not going to screw up badly enough to affect the cosmos itself. Um, that's nice. I think that's good.
Yes. So there's that word liberating again.
Yeah, yeah. No, yeah, I mean, yeah, I feel small and helpless. I'm okay with that. It would be nice if I were less helpless about my own existence, I guess.
Sure.
I that's appealing, but
Mhm.
nobody gets that,
Yeah.
right? Nobody gets to be that powerful over their own existence. People are making claims about it,
Yep.
as you know, as your book covers quite
Yes. Yeah.
extensively.
And some of those people also want to have control over the entire universe and screw
And
up
I'm
so
glad that they
badly.
don't.
Yeah, and they want to screw up so badly that they can destroy it.
Yeah,
Yeah.
yeah, yeah. No, I'm glad that they don't have that power. I don't think that they're gonna, ultimately prevail over, limits to their own existence. But for me, it's like it's okay. I don't It's okay to be small and insignificant sometimes, and I don't ever think that I'm not small and insignificant. And maybe that's the thing. I don't like if I get a reminder of it by staring into the abyss of the cosmos. Okay, I did know that. Like, I mean, you can have moments of, like, vertigo, right?
Mhm.
Where you realize that you're just this tiny little speck in this vast cosmic ocean, as I think Carl Sagan put it.
Yeah.
And the Artemis mission, Artemis 2, where they went around the moon and took lots of pictures of the Earth from very far away, seeing the Earth as this little small thing in the window. It's confronting, right? To realize
Yeah.
that even your whole planet is small and isolated and insignificant and just kind of tenuously floating there in the sea of black, right?
Yep.
That's confronting, but I think it's also awe-inspiring in a way.
Yeah.
And I kind of like that feeling of, like, oh, we're so tiny and insignificant. I think it's a bit thrilling.
This is why I'm asking you these questions. You just articulated that very, very well.
Thank you.
And I feel similarly. I mean,
Mhm.
I think that this is part of the appeal to me is to look at the whole thing and say, oh, look at this vast thing that I am a tiny,
Mhm.
tiny, tiny, tiny part of.
And that's always been wrapped up, like, this is the concept of awe,
Yeah.
right? Has always been wrapped up in terror, right? Like,
Yes.
that's where it comes from,
Yeah.
that idea, and I think that's okay.
Well, what you were just saying about Artemis sets us up well for something very exciting here. We have
Mm,
our first audience question from
amazing.
Patreon on Patreon, which is aimed directly at you because our patrons on Patreon get to find out who our guests are going to be in advance and ask questions of them or suggest questions for them.
Mm.
So this question comes from someone calling himself Toronto Will. He wants to know, can NASA's values like collectivism and strength through diversity withstand the onslaught both from Trump's presidency and from private space interests crowding them out of the field? Artemis was very reassuring that it hasn't happened yet, but it feels like borrowed time. Before you answer, I should say for our audience, Katie is an especially appropriate person for this, not just because Katie studies space, but also because Katie lives in Canada, but is from the US.
It's a good question. I also, watched the Artemis mission, and it was very nice to see something that was, like, displaying those values of, like, everybody's working together. There's a big international mission, lots of competent people being competent, just doing the work and making it go well. And, like, a lot of people had to rely on each other, rely on expertise, combine forces to do this very hard thing. And it involved not just NASA, but the European Space Agency, who built part of the capsule they were in, the propulsion system for the capsule they were in. The Canadian Space Agency was involved, of course. One of the astronauts was Canadian. And that was really comforting at a time when, like, it was at the same time when there's sort of massive international chaos, conflict, war, posturing, the kind of attacks against expertise, against science, and to see something where, the motivation for the mission was not purely about science, right? Like the motivation for the mission had to do with some of this national posturing, but it was a collaborative international mission, and there was science being done on it. Science that probably would not have happened if it weren't for the funding coming through this, national posturing thing. I'm glad that there was some science being done. I'm glad that it was a chance for people to see a crew working together so effectively, nations working together so effectively, and it was a diverse crew, which I appreciate seeing that value is also being on display. And they couldn't have chosen a better crew. They were just such cool people. It was so cool to watch that, the interactions they had and everything they had to say. And they also very much made the point that they were doing this for humanity, not for the glory of the nation.
Yeah.
Right. And I appreciated seeing that. But it's hard to know what the current administration is going to do to that, because although there's still funding for the Artemis program, there are massive attacks on funding for science within NASA.
Yep.
And a lot of people at NASA have been laid off. The number of people working at NASA is greatly reduced since the start of this presidency.
Yep.
And from what I hear, the culture at NASA is not where it was. People are really concerned about that now. A lot of people at NASA are very demoralized by the cuts, from what I've heard. This is all second, third hand. And I think that if these science cuts happen, it's going to be harder and harder to make these missions work, because a lot of the people who are working at NASA work at NASA because it's about science and exploration and advancing humanity in certain ways. And if everything is cut out except the national posturing and big rocket go fly, then it's not going to be appealing to the people who have that competence and that drive and that motivation. And it's going to be harder to get that stuff done. And the research that needs to happen for these missions to be successful is not going to happen. So I do worry about that. And with this new round of cuts, they're trying to cut something like half of the space missions, the science missions that are currently planned, which would be awful. So I don't know. I do worry about the future of NASA, the future of human spaceflight. I think that you can't just keep cutting and cutting and cutting and still get success with these missions, and that makes me worry for the astronauts and for the success of these missions. I hope that this is all very temporary. The last time the presidential budget included huge cuts, the Congress dialed them back, and the budget was restored. I hope that happens again this time. I know that a lot of people are campaigning very hard to keep the budget high not high, the amount of money that the administration spends on NASA science is just piddling. It's so little, especially compared to things like the defense budget or whatever. It's just astonishingly low. But I hope that these cuts are dialed back, and that the advocates and the people in Congress and so on are able to impress upon this administration that you can't just have the big rocket and not the science. I don't think that is a reasonable mix for an organization like NASA. I do worry, though, about a culture of sort of hostility to expertise, hostility to basic science.
Yeah.
All the innovation and the technology and so on is not sustainable without basic science, without exploration, without pure research. Those things need to be a part of it, or you can't have the big advances. It just doesn't work that way. And so I hope that that message gets across.
Yeah.
And I hope that this current administration does not manage to kick everybody competent out of these agencies. And I hope that whoever is in charge next reverses most of what's been done in the last 2 years. We have to see, I will, of course, keep advocating for science, for reason and expertise, and an understanding of how these things work and the value of international cooperation, the values of diversity and exploration. I will always advocate for that, but I think it's a hard road right now, for sure.
Well, hopefully there will be some light at the end of it. And if there isn't, the universe will end. So either way.
Yeah, exactly. Right.
And
Either way, the universe will end.
yeah, either way, the universe will end. So I think we're going to end the
We can have
podcast.
this little light now or not.
Yeah, exactly. So we're going to end the podcast there.
Okay, great.
Katie, it has been such a pleasure having you on the show.
Thank you.
And once again, your book is The End of Everything, Astrophysically Speaking. Everybody, please go out and get it. And you can also follow Katie on social media, or you can join her legions of followers. And the new book, again, Katie, what's the title and when should we be looking for it?
So it's called How to Build a Universe, Theoretically Speaking. And at the moment, we're looking at sort of early 2027 for the release date, although I think that the pre-orders will be sooner than that. So I don't know exactly when, sometime in the next few months. We already have a cover, which I think looks great. I can't show it to anyone yet. I showed it to you, Adam.
Yes,
you've seen it.
It does look really good. And
I think it's really cool.
Yeah, no, I think
yeah.
it's great. And I'm excited to read it. But
yeah, you can follow me online. I'm on Blue Sky as @astrokatie.com. There's my website, astrokatie.com. On my website, you can sign up for my newsletter, which I have not produced in about 2 years, but I am going to have some new issues soon because I need to put out some stuff about the book. So if you do sign up for the newsletter, I promise it will not be a long wait before you get actual content from that. And then I'm also on Instagram at Katie Mack. And I'm occasionally on TikTok as Katie Mack, although not often, but once in a while.
Well, talk again soon.
Thanks. Great talking to you as always.
Thanks again to this week's guest, Katie Mack. Next week's episode is going to be a little bit different. I was invited to give a talk and do a Q&A at University College London. So in a way, I'm the guest next week. See you then. To submit questions for future guests and to suggest other guests and to see more pictures of Babka, join the conversation on Patreon. You can also find us on YouTube, on Instagram at DATMpod, on the web and on Blue Sky at dreamingagainstthemachine.com, or just find us wherever you get your podcasts. Dreaming Against the Machine is a proud member of Multitude Productions. Our executive producer is Nick Carissimi. Our associate producer is Rosie Thomas. Our theme music is by Jared Emerson Johnson. Our show logo is by Nick James. And our fearless leader is Babka, the greatest cat in the observable universe. I'm Adam Becker, and I'll see you next week.